Bismillahirrahmanirrahim. Assalamualaikum. Students, our topic for discussion is water soluble vitamins, and today we discuss about the vitamin B7, or it is called as the biotin. It is the water soluble vitamin. It is called vitamin B7 according to some authors, vitamin B8, and also the vitamin H. It is called as the vitamin H because A and I. These are the German words meaning hair and the skin. The biotin is a coenzyme in the carboxylation reactions in which it serves as a carrier of the activated carbon dioxide. It is also called as its coenzyme is called as the coenzyme R according to some authors. Biotin is a coenzyme for carbon dioxide fixation reaction. It serves as a prosthetic group for the ATP-dependent carboxylase. For example, pyruvate carboxylase, acetyl-CoA carboxylase, and proponyl-CoA carboxylase. Sources: it is widely distributed in various foodstuffs, but important and rich sources of the vitamin B7 are the liver, yeast, peanut, kidney, and egg yolk. Also, the intestinal microflora synthesize the vitamin B7. RDA 30 to 100 microgram per day is required. It is the structure of the biotin. The biotin consists of an imidazole ring that is cis-fused to the thiophene ring, bearing a valerate side chain. The valyl carboxyl group is attached to the epsilon amino group of a lysine residue in an apoenzyme. This nitrogen is responsible for carrying the carbon dioxide. This is the structure of the biotin, and here is the coenzyme structure of the biotin. The coenzyme form of the biotin is called as the enzyme-bound biotin or the biotin, in which it linked with the apoenzyme through the lysine residue. Biotin is mostly bound to the type 3 protein by an amide linkage, and this linkage is cleaved prior to the absorption of the biotin from the intestine. Coenzyme function: biotin is covalently attached to the apoenzyme by an amide linkage with the epsilon lysyl amino group. Biotin serves as a carrier of the activated carbon dioxide, transferring it to the various receptor molecules with the help of the enzyme hollow carboxylase synthetase. Basically, hollow carboxylase synthetase catalyzes the transfer of the biotin onto the lysine residue of the apoenzyme to form the biocytin residue of the hollow enzyme. The reactive intermediate is 1N-carboxy biocytin formed from the bicarbonate in the ATP-dependent reaction. The carboxyl group is then transferred to the substrate for the carboxylation. The most important carboxylation reactions are conversion of acetyl-CoA to the manonyl-CoA with the help of the enzyme acetyl-CoA carboxylase. Here biotin acts as a coenzyme, while the conversion of pyruvate to the oxaloacetate with the help of the enzyme pyruvate carboxylase, and the conversion of the proponyl-CoA to the methyl malonyl-CoA with the help of the enzyme proponyl-CoA carboxylase. These are the important reactions in which the biotin acts as a coenzyme. However, there are some reactions in the body which is independent of the biotin for the carboxylation reactions. And it is also important for the viva point of view question. Formation of the carbamyl phosphate by the carbamyl phosphate synthetase, vitamin K dependent carboxylation of glutamyl residue of several clotting factors, conversion of pyruvate to the malate by the malic enzyme, and addition of the carbon 6 to the purine. All these reactions do not require the biotin as a coenzyme for the carboxylation reactions. Also, there is important role of the biotin. Biotin also has a role in the regulation of cell cycle, acting through biotinylate key nuclear protein. Recycling, it is an important point according to the biotin. Proteolytic degradation of the biotin containing enzyme. Both in the intestinal lumen and in the tissues produces the biotinyl lysine or the biocytin. It contains of the biotin bound to the epsilon group of the lysine. Biotinylase is the enzyme which cleave the biocytin to the biotin and the lysine, thus biotin is recycled. Deficiency, biotin deficiency does not occur, and its deficiency is very rare because the vitamin is widely distributed in various foodstuffs, and also the microorganisms synthesize the biotin. So its deficiency is very rare. However, it is related with the excessive use of the raw egg white as a source of the protein. So it induces the symptoms of the biotin deficiency, and these include the dermatitis, glossitis, loss of appetite, and nausea. The raw egg white contain the glycoprotein avidin, which binds with the imidazole group of the biotin tightly, so it prevents the absorption from the intestine. And this may occur if more than 20 raw eggs daily use, otherwise no. And also sometimes prolonged antibiotic therapy causes the deficiency of the biotin. So in short review, biotin is the vitamin B7, or also called as the vitamin H. It is also used in some creams, shampoo, and also the cosmetics. It is used to prevent the hair loss and also in some skin problems, but it is very poor. Its absorption is very poor from the skin surface. However, the major function of the biotin is it serves as a coenzyme for the carboxylation reactions. Each carboxylation reaction requires the ATP, biotin, and the carboxylase. However, in the body there are some reactions which do not require the biotin as a coenzyme for the carboxylation. For example, CPS1 and the CPS2 carbamyl phosphate synthase. Another vitamin K dependent carboxylation of the clotting factor also do not require the biotin as a coenzyme. However, the biotin is widely distributed in various foodstuffs. So its deficiency is very rare, and also its RDA is approximately 30 to 100 microgram per day. The microflora, intestinal microflora, also synthesize the vitamin B7. However, its deficiency is rare, but sometimes it is related with excessive amount of the raw egg white use in the diet as a protein source, or sometimes prolonged antibiotic therapy also cause the deficiency of the vitamin B7. It was all about the biotin or vitamin